Good morning, class. This morning we'll be looking at magnets. Okay. The word here is magnetism, the properties of magnet. Years back, magnet was discovered in what we call magnetite, iron 3 oxide. And then scientists began to work on it, or artisans in those days worked on it. And now we have what we call magnet in our present days. I'll look at these objectives today. First, a magnet. Second, properties of a magnet. Third, magnetic and non-magnetic object. And then fourth, we look at soft magnets and permanent magnets. Now, these are pictures of magnets. This is the horseshoe magnet. This one is a bar magnet, this is a round magnet. Many of you have seen magnets before and have even used magnets. We have some that looks dark in color. You can see magnets, they attract objects. The magnet is an object that can attract all other objects. Some other object, not all, per se, some other object. Now it will shock you to know that even the earth itself has its own magnetic properties, because the earth attracts all objects on its surface. Properties of magnets. One, attracts other objects. Magnets can attract other objects. They can't attract all objects, but they can attract some certain objects. Like magnets can attract iron, can attract steel, can attract some special alloy, can attract nickel, and so on and so forth. There are some certain metals that cannot be attracted by a magnet because they have no magnetic property, but in the face of very strong magnets, they become attracted. Now, we also have magnetic poles. All magnets have two poles, the North Pole and the South Pole. The poles of the magnet are those regions in the magnet that are strongly magnetic, that have strong attractive properties. Then direction of the poles of magnet when freely suspended. How do we know a magnet? Anytime you suspend a magnet freely like this with a rope, you notice that the magnet is going to rest in a position such that its north pole will be facing the Earth's geographic north, and then the south pole will be facing the Earth's geographic south. All magnets, when freely suspended, that is where they come to rest. Their north pole will face the Earth geographic north, and then their south pole will face the Earth geographic. We will explain this one in the Google class, why it is always like that. Now, the laws of magnetism. Laws of magnetism. Okay, when you bring two north poles together, they will repel each other. You bring two south poles together, they will repel each other. But when you bring a north and a south pole together, they will attract. We are trying to say, in the laws of magnetism, okay, like poles repel each other, while unlike poles attract each other. Magnetic and non-magnetic objects. Here we have a list of magnetic objects and then list of non-magnetic objects. As we said, your iron, your steel, your nickel, your cobalt, and also special alloys, they are magnetic. Okay, non-magnetic objects. Your paper is non-magnetic, wood non-magnetic, and other things like that. Non-magnetic. We see them in our day-to-day life. In this very place, if I take a magnet and I place in some of the aluminium windows here, you see that it won't be able to attract them because it's not magnetic. Now, temporary and permanent magnets. Okay, I'll round up with this today. Temporary magnet. I just wrote out the characteristics here. Okay, easy to magnetize, easily demagnetize, formed from soft iron, and then it has strong magnetic property. Now, the permanent magnet is just the opposite of temporary magnet. What we call a magnet temporary is that it can be easily magnetized and it can easily lose its magnetic properties. Okay. Why the permanent magnet is a magnet that is not so easy to magnetize, and then it does not easily lose its magnetic properties. Generally, temporary magnets are made from soft iron, while permanent magnets are made from steel. I will stop here. In the Google class, I'm going to go into details with you. Thank you very much.